Welcome to the deep dive. Today we're jumping into something pretty fascinating. The big shifts in how humans and computers interact. HCI.
Right, human-computer interaction. And the big goal really has always been to make it seamless.
To close that gap, that gulf of execution they talk about.
Exactly, the gap between what you want to do in your head and all the fiddly steps the computer makes you take. It's always been about shifting that, cognitive load onto the machine.
Okay, so let's map that history. Three main epochs, right? First up was the CLI.
The command line interface. Think old school DOS or Linux terminals.
All text. You had to recall the exact commands, like cpp-v file1.txt backup. If you missed a space, forget it.
Precisely. Total precision required. The human had to bend completely to the machine.
Yeah.
Very demanding.
Which made the next step, the GUI, feel like such a breakthrough. Epoch 2.
Oh, absolutely. The graphical user interface. This was revolutionary because it shifted from recall to recognition.
Windows, icons, menus, the mouse pointer. WMP.
Yep, the One Piece paradigm. Suddenly you could see things, point, click, drag. It felt like manipulating real objects, thanks to things like the desktop metaphor. Much more intuitive.
And that brings us to now. Epoch 3. What are we calling this one?
Agentic intelligence interfaces. AII. This is where it gets really interesting.
This is the era of delegation, right? Where you don't specify the steps, just the outcome you want.
Exactly. Think of advanced LLMs, AI agents. You tell them, hey, achieve this goal for me. They figure out the how.
It feels like we're often interacting with these through voice, though. Chatbots, smart assistants.
Yes, and that's the dominant transition phase right now. But here's the core argument we're seeing in the research, the kind of central thesis. Voice isn't the end game.
Oh.
The truly transformative leap, especially for controlling things in the real world, looks like it'll be a fusion.
Mm-hmm.
High bandwidth, brain-computer interfaces, BCIs, combined with sophisticated robotics.
Okay, hold on. Voice feels so natural. Why argue? You called it a cognitive regression. That sounds counterintuitive.
Well, think about it. Talking is linear, right? One word after another. Serial.
Yeah.
It's like the old command line.
Yeah.
Our actual thoughts, our intentions, they aren't like that. They're massively parallel. We juggle multiple ideas, constraints, goals, all at once.
Ah, okay. So trying to squeeze all that complexity through the narrow channel of spoken words.
It's a huge bandwidth mismatch. It's just, well, it's absurdly slow and imprecise for complex control, especially for fine motor tasks or interacting with the physical world dynamically.
But these AI models are getting so good at understanding context. Doesn't that solve the ambiguity problem?
Not entirely. There's this persistent issue, sometimes called the incurable plague of ambiguity. Specifically, pragmatic ambiguity.
Pragmatic ambiguity, meaning?
Meaning the AI might understand the words you said, but it fails to grasp your true intent behind them. Why you said it, what you really mean to achieve. Natural language is just inherently fuzzy like that.
Okay, so that's where BCI comes in as the superior path, at least for certain applications, like robotics.
Precisely. Because BCI aims to tap directly into the brain's signals before they get translated into language. It's like accessing the source code of intention.
It's from the motor cortex, right? The intent to move.
Exactly. It decodes that high-fidelity parallel intention directly, skips the whole language bottleneck.
And this isn't just theory. We're seeing practical examples now.
Absolutely. There's empirical validation. People with paralysis using BCIs to control sophisticated robotic arms, performing complex tasks like grasping objects. It works.
The robot becomes like an extension of their own body.
That's the idea. The human-machine centaur. The human provides the high-level goal, pick up that cup, and the AI and the BCI and robot handles the low-level stuff, calculating the trajectory, grip force, avoiding obstacles. Of course, we need to mention BCIs often come with challenges like surgery or significant power needs.
This direct mind-machine link, though, it opens up a whole new set of problems, doesn't it? Things the CLI and GUI never presented.
Definitely. Huge challenges. Neurosecurity and privacy become critical.
You mean like brain hacking, someone intercepting or even manipulating your neural signals? That sounds terrifying.
It's a serious concern. And then there's the legal and ethical side. Accountability.
Right. If agency is shared between the human mind and the machine and something goes wrong, a BCI-controlled arm causes harm. Who's responsible?
Exactly. Was it a misread signal? Faulty hardware? A conscious bad intention? When that interface dissolves into the mind itself, tracing responsibility gets incredibly difficult.
So wrapping this up, what's the big takeaway for us thinking about this future?
Well, it goes beyond just making things easier to use, this intimate merging of human consciousness and machine capability. It really starts to challenge our fundamental ideas about what it means to be a person.
How so?
It radically shrinks the distance between thought and physical action. So the final thought we want to leave you with is this. When our minds themselves can be technologically mediated, interacting directly with the world through machines, what does that do to our definition of human ability and maybe even, humanity itself?
Yeah.
What emerges then?